In this video, we're going to discuss Descartes' Rule of Signs. So Descartes' Rule of Signs tells us about the real zeros of a function. It tells us how many positive zeros there might be and how many negative zeros there might be. So if f of x is our polynomial, then if we look at the number of sign changes, so if we put the terms in order from highest degree to lowest degree, and then we follow from left to right and we count the number of times the sign changes between positive and negative. That's what we mean by sign changes. So so the number of positive zeros of the function is either the same as the number of sign changes or it's less than that by an even number. And the number of negative real zeros will be determined by looking at f of negative x. So we would need to find f of negative x and then count the sign changes for it. And that will tell us whether the original function, how many zeros the original function has. Again, it'll either be the same as the number of sign changes or less than that by an even number. So for example, we have this function here. So the terms are lined up in decreasing order. We've got the fourth degree term, then the third degree term, etc. And so if we look, the first term is positive and the second term is negative. So there's one sign change. And then we go from a negative term to a positive term. So there's a sign change. And positive to negative. So there's another sign change. And negative to positive. So there's another sign change. So we had 4 sign changes here. So Descartes' rule of signs says that this function f of x has either 4 positive zeros, or it may have less than that, but it has to be less than 4 by an even number. So for example, we know there are not 3 positive zeros here because 3 is less than 4, but it's less than 4 by subtracting 1. So we need to subtract even numbers from 4 to get the other possibilities. So if we subtract 2 from 4, we get 2. So there might be 2 positive zeros. Or if we subtract 2 again, we get 0. So you can just keep subtracting 2 from the number until we obviously would not put a negative answer because we're counting things. So negative would not make sense. So this function either has 4 or 2 or 0. I should write or here. Or 0 positive zeros. Okay, now to count how many negative zeros this function has, we need to look at the sign changes of f of negative x. So we'll find f of negative x. So just like when we find f of anything else, we're putting the number in parentheses in as our input. So we're replacing all of the x's in the function with negative x. And so once we've done that, we need to kind of simplify things so we know whether the terms are positive or negative. So if we raise something negative to an even exponent, it's actually going to come out positive. So that first term is positive x. But if we raise something negative to an odd exponent, it's going to be negative. So that negative x cubed is going to come out as negative x cubed, and then we'll multiply that by the negative 14 that's there. So that term becomes positive. Then we have a negative to an even exponent, so that will be positive. And then we have negative 154 times negative x. So that will be positive. Positive. So for f of negative x, there are no sign changes. All of the terms are positive. And that means our original function f has no sign changes, because the number of sign changes, it's either the number of sign changes or less than that by an even number. Well, we can't go negative, so f of x, the original, has no negative zeros. All right, here we have another example. So if we count the sign changes here, since all the terms are in decreasing order of degree, we go positive to negative here, then we go negative to positive, then we go positive to negative, and we don't have any more sign changes after that. The rest of the terms are negative. So we have 3 sign changes here. So the number of positive zeros is either 3 or less than 3 by an even number. So if we subtract 2 from 3, we get 1. And if we were to subtract 2 again from 1, we would have a negative number. So that does not make sense. So f has either 3 or 1 positive zeros. I'm going to put that in parentheses because it might be 1 0 or it might be 3 zeros. All right, and then to figure out how many negative zeros this might have, we need to look at f of negative x. So again, we'll just replace all of the x's with negative x. And so we get 4x to the 4th. Then we have a negative times a negative there. We square a negative, but still positive. Negative times a negative for this term. And then our minus 6. So we start off with a positive term, and they stay positive all the way till the end. We have 1 sign change here. Okay, so our original function f of x has 1 negative 0.